Hello, and thank you for asking me to be here, Sonia, Mary Jane, and Colin. Thanks. Shorty. Just hold on, here we go. Sticks and Stones. The reason I've called it Sticks and Stones is that because nothing defines a culture as distinctly as its language. And the element of language that best encapsulates a society's values and beliefs is its proverbs. And you all know the proverb, sticks and stones may hurt my bones.
Speak up a bit.
Speak up. Sorry. Do you want me to repeat that? Did you hear it? Being repeated, okay. I've chosen the title Sticks and Stones, okay, simply because it's a proverb and nothing defines a culture as distinctly as its language, and the element of language that best encapsulates a society's values and beliefs are its proverbs, or is its proverbs. So when I was looking up what proverbs do and say for a society, somebody with a lot of time on their hands made up this graphic. And basically, the size of the word reflects the number of times it appears in all the proverbs. So I'm pleased that good is in there, I'm pleased that better is in there, but never, no. Anyway, the proverb, as you know, is sticks and stones may break my bones, but names will never harm me. And I think that ME is one example where that's absolutely not true, where the name is a problem for the patients, for the doctors, and for the public. So you can see from this slide what the problem is with the name, and I don't think there's a person in this room who hasn't felt the bad end of the name ME, or had an argument with somebody who called it CFS. But as a professional, what do you do when you're faced with unrelieved suffering of no known cause and treatments that have continually provoked suspicion? So the medical profession got together and tried to constitute a diagnosis. The problem with that was that it was going to be a diagnosis of exclusion. What isn't this illness? There's nothing to confirm it, we don't have a biological test, and we don't have an anatomical sign. There is nothing yet that we can see that actually defines the syndrome. They might define a symptom, but not a syndrome. So when we get a collection of symptoms, we've got to know what to expect before we can actually make the diagnosis. The problem is, which of those symptoms are going to make the cut? So part of what we've got to do is to disambiguate what syndromes and symptoms there are and look at the disorders that actually overlap. For example, the classic ones are chronic fatigue syndrome and fibromyalgia. They're different ends of the spectrum. With chronic fatigue, you get some fibromyalgic points. With fibromyalgia, it's often accompanied by fatigue. So which diagnosis is it? Where on that spectrum do we actually put a pen and say, we've actually got both? Is there a difference? Do they occur together? Are they the same thing, just different ends of the spectrum? So that's quite difficult. So one of the sets of criteria that I'm particularly fond of is those drawn up by a man called Reeves, who unfortunately died a couple of years ago. And what he said was that these symptoms have been around for nearly 200 years, and what are we making such a fuss about? Why don't we just get on and treat the symptoms? Yeah, that's all very well, but what happened was this. We have a number of criteria that have yet again in this illness caused controversy, frustration, and anger. And the problem with all of this is that, you know, if we're too specific about the criteria that we use to include, we're going to have very specific syndromes, separate ones that all overlap. What are we going to treat? And the problem with that is comparing different syndromes and with different criteria. How do you actually do any meaningful research? Because we're going to start comparing oranges with lemons, and our outcomes aren't going to be believed by anybody. So, on the other hand, if we're too vague, we're too inclusive, and the same thing applies when we're going to be comparing oranges with lemons and have nothing definite to go on. The other side of this coin, in not having criteria, is that it's not just about criteria and the theory of criteria. It's about the diagnosis for the patient. The patient's going to need a diagnosis in order to get benefits, to choose a therapy. So it is quite important to have a name, after all. And the other thing is that, the other side of that coin is that in choosing a name, we're going to cause offence, no matter what we do. Whether I call it ME or CFS or CFS or ME, or post-viral fatigue syndrome, and all the rules that apply to making those definitions. Personally, I'm not sure we should stick so strictly to them, and I'll explain that as I go on. If any of you are interested and have some time, however, there's the Department of Health, or the Chief Scientist Officer, as it's called in Scotland, has actually written a document which is absolutely excellent in looking at the pros and cons, and they chose the Canadian criteria to use in Scotland. I'm not sure I would have agreed with them, not because I don't like the Canadian criteria, just because I'm sorry to be so definite and choose one set of criteria. But I'm sure Colin, if any of you are interested, can circulate that link. So, the reason I've got this picture of Cinderella is I think because of all of these things, because of the anger, the frustration, the uncertainty, the distress, the illness, that it's been very difficult for those running services for fatigue to actually remain in the mainstream. We used to be very much a dumping ground. Anything that couldn't be solved in any other discipline came to chronic fatigue, or send them to liaison psychiatry, put them on antidepressants, and make them run around the building 2 or 3 times. And that, unfortunately, very unfortunately, is a view that still prevails. It's getting less and less, but it's taken a hard time. So we have been a Cinderella service, and as a Cinderella service, we haven't attracted funding. Now, this is actually quite a nice picture of Cinderella. She's usually in rags with the broom, with the coal on her face. And the reason I chose the nice one is that because some of those services, whether we're in a Cinderella setup, are actually really, really good. We do work for the patient. We have to fight a lot of fights, but we are quite nice, and we do smell nice. So now, if that wasn't enough, with all the frustration and anger and everything that's out there, when it comes to the doctors themselves, some of us take 2 different views. Some go the biomedical model, and some go the biopsychosocial model. I'd like to very briefly say why I think it's not helpful. It started with Hippocrates. He was the first man, he was known as the father of medicine, the first man to coin the term psychosomasis. He said body affects mind and mind affects bodies. Personally, I don't know how you can separate them. We've got a spinal cord going from the brain to our butt, one end to the other. The man who took over from him, a man called Galen, was very, very influential, and he mostly stuck with what Hippocrates said. He adhered to what were known as the humours. For example, there are 4 humours. For example, melancholy was associated with bile, which probably has given bile its bad name, bitter and twisted. However, he actually continued to believe that, became a bit more mechanistic as whatever technology was in those days moved forward. He was really highly respected, simply because he was the physician to the Emperor Nero. And he also was a physician to the gladiators. That's just a picture of a gladiator in case you didn't know what one looked at. That galenic body of work actually lasted till the early 16th century when a Frenchman called Monsieur Descartes came along. Now he was a philosopher. Philosophers at the time had great influence, especially on emerging disciplines like medicine. And he became very biomedical, dropping the psyche. He said the mind and the body were not connected, and the mind and the soul would not fail, the mind or soul, sorry, making them the same. Religious overtones in there. The mind or soul would not fail to be what it is, even if the body did not exist. Some of his arguments, and there are quite a lot of them, whilst he was an excellent philosopher, some of the arguments are absolutely counterintuitive, and one of the best examples I can use is what do you do when you're in love, because there's mind and body in there, and anybody who says there isn't, come and see me. So, looking at this biomedical model, it reigned very much until the 19th century, post-industrial revolution, where it became disease and pestilence and what do we do about it. And medicine as a profession was divided into four branches, four basic branches, not too dissimilar to what we do today: anatomy, physiology, biochemistry, and pathology. Until Dr. George Engel came along, an American who developed the biopsychosocial model. And he said that health is best understood in terms of a combination of biological, psychological, and social factors. He wrote exceptionally well, and if any of you want to look at his second article in the clinical applications of biopsychosocial, it's actually incredibly well written and very, very persuasive. That's basically what it is. But I think what's really interesting is the third point here: access to technology. Technology has made a huge difference to how we perceive our health. I have patients who come in and mention something to me, and I there and then in front of them have to use Google. That's one aspect of it. The other aspect of it is that patients become much more confident with what they see on the internet and how it relates to their symptoms. At a certain level, that de-skills the doctor, which isn't a very nice feeling, I have to tell you. I'm very grateful for Google. What about the view of biopsychosocial medicine? It's generally the view, although there are some still who believe, that there is a direct causal link between psychological and social and chronic medical illness. Conversely, social and psychological factors are important indirect factors when we are to mediate risky behaviour. The real evidence for the biopsychosocial model is when it is determining disability associated with chronic medical illnesses, and that's really why we can't actually ditch it as a model. Robert Kendall, who's a psychiatrist, is actually one of my favourite people because he was the first one to come out very, very clearly in two beautifully written articles to say that the distinction between mental and physical illness is ill-founded and incompatible with our contemporary understanding. More of that later. But what he went on to say is that if we do continue to refer to mental and physical illnesses, we should preface both with so-called, to remind ourselves and our audience that these are archaic and deeply misleading terms. And the reason I'd like to use three very brief examples, although Keith has covered the principle, is that in diabetes, there are multiple symptoms that involve the pancreas, the gut, the heart, the brain, and the nervous system. That doesn't mean that there are 5 different diseases. It means that there is one cause and its effect on the whole body results in these particular categories, and we do treat those manifestations, symptoms, we do treat those each separately. The same with rheumatoid arthritis, which has a psychological and psychiatric component to it that is distinctly as a consequence, what may also not be a consequence, but has been shown to be part of the actual illness, and the pathogenesis of that illness, and exactly the same goes for lupus. So, it hasn't made us any less of a Cinderella, but I really know that I want to go to the ball and I want to glue my shoes on. I'm not using any slippers, and I think it really is for us the only way forward. And I will try and describe what I do at my service and what model we use. It's called Psychoneuroimmunology, PNI. There's lots of stuff on the internet if you want to go and look at it, but I hope I'll be able to describe it here. Whoever coined the term should be shocked, because starting any illness with psycho is not a good idea. However, we're stuck with it, and let's move on. It's an evolutionary model, which is partly why I like it. It's scientific in approach. I'm scientifically trained. It's also applied across other disciplines, for example, psychoneuroendocrinology, with great success. And it also takes in the best of the biomedical model and the biopsychosocial model. I'm not sure how I'm going to do this because I can't point to what's on the diagram and speak at the same time, but I'll make an attempt. Okay, so this is very diagrammatic. It encapsulates the PNI model. So basically, the central part is the brain, connected completely from the hypothalamus in the brain to the pituitary, to all the glands that secrete hormones. Then there's the immune system and the peripheral nervous system, which makes it into psychoneuroimmunology. Now, as you can see, they're all connected. They all have reciprocal interactions at various levels throughout their going from top to bottom. What we believe is in the psychoneuroimmunological model is that whatever happens in the limbic system is often called the reptilian brain. The reason for that in evolutionary terms is that in reptiles it's the first place that you actually anatomically see this part of the brain, and it's very much a binary facility. It's an all or nothing, it's a fight or flight. So the snake either comes and bites you, or the snake slithers away. We either have an argument with someone and we want to off them, or we run the other way. Very, very basic. Now, thankfully, as we've evolved, we've become a lot more sophisticated, and there are a lot more nuances in there. Whilst that's fabulous for us in a social sense, it's not so great for us in a physical sense if it starts to misfire. The other thing about the limbic system is this, it's going to be your left, you can see that almond-shaped structure. That's actually called the amygdala. All the amygdala means is it's almond in Greek, but it represents the equivalent of a hard drive in the limbic system. So whatever emotional experiences we have, good or bad, are actually hard-written to the amygdala. I'm going to come back to that later. So something happens, you become really, really stressed. You've seen a snake, you've seen 10 snakes, and there's two things that happen. There's an immediate connection to the nervous system, and via the nervous system there's an immediate connection to the immune system, which is also supplied by nerves. So what happens then is that lymphocytes, which are some of the white cells in the immune system, become activated. I'm going to get a bit more specific on the next slide, but this is just the overview. So they become activated. When they become chronically activated, they release cytokines. Now, cytokines are just the messengers of the immune system who talk to the hormones, who are the messengers of the HPA, who talk to the neuropeptides, who are the messengers of the nervous system. Now, as you can see, if something goes wrong there, the concertina effect goes back and forth and up and down and round about. And that's why in ME we get the symptoms that we get that involve the nervous system, the brain, the HPA, and the immune system. Just an example of how this system was designed to be adaptive to allow us to survive as a species. Some of the cytokines, for example, interleukin-2 and interferon, you may have heard these terms bandied about on television when they're talking about cancer. Now, when they're secreted, IL-2 actually causes you to be fatigued. IL-6 causes you to have enlarged lymph nodes. The reason for that is, in caveman days, when you were sick, an adaptive mechanism was to make you tired, make you lose weight, so that you didn't go out foraging for food, because if you went out foraging for food when you were feeling sick, big grizzly bear was going to come and get you. End of species. That's an adaptive mechanism. For example, we have temperatures when we are sick. That's because bacteria and viruses don't like heat. So that's one of the reasons that we develop a temperature. Why do we have iron in our bodies? One of the reasons is that, and why does our iron go up during an infection in our bloods and our stores go down after an infection? Because iron chelates. It latches on to microbes. So those are adaptive mechanisms. The problem with chronic fatigue is that we've probably become maladaptive. Where along the line, we don't know, but I'm going to try and explain. Okay, so there's lymphocytes that I was talking about. There's various types of them. The one we're interested in for this purpose is called a T cell. More specifically, a T helper cell, hence the TH. Okay? So we start off, the immune response starts off at neutral. The T helper cell is doing nothing, it's just waiting for a trigger. And what happens when an infective trigger comes along is there's two cytokines that are released. One is called IL-2, IL-12, interleukin-12, and the other is interleukin-10. Now, they stimulate different parts, cascades of the immune system, depending on what the trigger is. So they recognize whether this is a virus, a chlamydia, a mycoplasma, a yeast, and even cancer cells. The other side recognizes bacteria, parasites, toxins, and allergens, which usually are outside the cells. The viruses and chlamydia and mycoplasma are inside the cells. So they recognize the different pathogens. They use different cells to kill those pathogens. Some use cytotoxic cells and natural killer cells, which I'm sure you all have heard of with respect to ME. And the others use polymorphonucleosides and eosinophils and antibodies. They used to be called cell-mediated immunity and humoral immunity. They're now called Th1 and Th2. The theory about ME is that that patients who have ME is that they get stuck on one side. In a healthy immune system, you would move from one to the other, one to the other. It would be very dynamic. What happens, I believe, in this illness is that it becomes static and we get stuck on one side. It becomes germ warfare. The problem being, or the reason being, that viruses particularly, but lots of pathogens, specifically the herpes family, and that includes Epstein-Barr virus because it is one of the herpes family, cytomegalovirus, one of the herpes family, and other intracellular pathogens such as mycoplasma and chlamydia. IL-2, IL-12, and IL-10 actually secrete proteins that mimic these viruses. They become clever. So in other words, they can stay around in the body longer. It's a way of ambushing the immune system. So we can either have a predominantly antibody-forming immune system or a predominantly cell-mediated response to a threat. Sorry. So when you come back here and you see that those cytokines are being secreted in abnormal amounts, you can see the consequence. You're going to get hormonal abnormalities, you're going to get temperature fluctuations because the hypothalamus is now affected. And in the periphery of the nervous system, we have the autonomic nervous system, which is divided into the sympathetic and the parasympathetic. Now, the sympathetic is what keeps you awake during the day, it keeps your heart pumping, it keeps your gut moving because you're eating, and it keeps you peeing, all of those things. When you go to sleep at night, your parasympathetic nervous system takes over and it puts your brain into less of an overdrive. It slows your heart rate, it stops your gut from contracting, and it, except for old men with prostate problems, it stops you getting up to pee, so you have a proper night's sleep. Now, you can see by the cascade and the reciprocal interactions, if you get stuck with a maladaptive reaction, like the overstimulation of one side of the immune system, or the cytokines that normally present to keep this system in dynamic flow, if that's mimicked by a virus, then you can see how it can continually go wrong and you get stuck on a spiral and you can't get out. The problem is that we can't find just yet how that happens, but we haven't even got to finding the DNA of the viruses that may be concerned. Which is where I think we need to start doing different kinds of research. I don't want to go into too much because I know that Sonia and Mary Jane are going to do that, but I'd just like to talk about one or two that we're doing at the Royal Free, or collaborating with at the Royal Free. And this one I think is particularly interesting, partly because I work in hepatitis C with co-infection of HIV, as well as chronic fatigue. Basically, am I doing okay for time? Yeah. Basically, there's a large body, I'm losing this, sorry. There's a large body of research showing immune dysregulation, although we can't actually classify it, but there is immune dysregulation in CFS. We know that there's an infective trigger in many, many cases, and my guess would be that when people don't think there's an infective trigger, yes, there has been, they just didn't know it, as often happens with EBV. I tell people that they've had EBV and they say, what? Never. But the blood says yes. There are elevated levels of pro-inflammatory markers, IL-12, IL-10. There's presence of neuroendocrine abnormalities. POTS is one very, very obvious example, and I don't think POTS is a separate disease, it's just another manifestation of chronic fatigue syndrome and the whole system that's been put awry. That's why I'm not talking about it too much. I leave that to Julia Newton, who's much better at it than I am. And there are also symptoms similar to behavioural disturbances occurring in the context of pro-inflammatory conditions. If you look at other pro-inflammatory conditions, it makes you, the rise in adrenaline, and adrenaline makes you stressed. So we're looking at interferon alpha, which is a treatment for hepatitis C, and what it does to patients whilst they're on that treatment. They develop fatigue first, and then about 4 months into the treatment, they develop this profound, really horrible depression that is incredibly difficult to treat. Interestingly, that depression resolves when they finish their year's treatment of interferon alpha. So at King's, they're taking people who are hep C positive and are going to be treated with interferon alpha, and those with chronic fatigue syndrome, and comparing their inflammatory markers. It should be a very interesting study. The next study is the brain and pain, and I know Sonia's going to mention that, so I'm actually not going to say anything more. Also, there's no ethics for our site at the Royal Free yet, so I can't really say any more. What else are we doing at the Royal Free? One of the symptoms that has been increasing in presentation in my cohort of patients is tinnitus. Now, over 60, the ear's not working so well, it's not clearing itself, that's okay, but it's younger and younger patients are describing tinnitus. So I thought, is this like POTS? Is it just another manifestation of what's gone wrong? Or is it something else? So I contacted, I thought we'd do a little audit, and I contacted the Tinnitus Research Collaborative. And this is what they sent me. As you can see, it's incredibly complicated, what's new about chronic fatigue and anything to do with it. And so I am going to persevere with it because we've actually got an audiology department, an ear, nose, throat department who are really interested in doing this for nothing. They want no money. They just want their name on a paper if we get to a paper. So that's really useful. And it's a very, very debilitating symptom. I don't know if you've ever had it. The other thing that I think we really need, I think we must stop being so caught up in terminology. I agree, and I've made those points. I think it can be important. It can be important for the patient to know what is wrong with them, what doctors think is wrong with them. It's important for their benefits, and it's important for their work. It's important for them moving forward. I'm not saying ditch everything. I do think, however, we do need an international consensus on post-infectious fatigue. And I think that's what we really need to go back calling it. I think our Cinderella, we really will be at the ball at that point. We'll be dancing at the ball. And the other thing, which is slightly connected, is that a NAT, a nucleic acid amplification test, it's looking at the very DNA of microbes. And in genitourinary medicine, where I work part-time, we can tell that somebody's got chlamydia from the tiniest piece of their DNA. There are one or two minor quibbles with it, but I think we should get a generic NAT, test everybody and see what kind of DNA we come up with. Are we coming up with any chlamydia? Are we coming up with mycoplasma? And these organisms, that microbes that can actually mimic our cytokine cascades, might give us a clue as to the disease. How we're going to treat it, I'm not sure, but at least it's one step closer. Oh, that's it. Thank you.